The Elbe Tunnel in Hamburg, a predictable traffic bottleneck. Many drivers choose to cross the River Elbe by the fastest and most convenient route. During the past 20 years, this has led to a rapid increase in traffic volume, to a daily average of 110,000 vehicles. This can result in tailbacks of many kilometers from the tunnel entrance. This problem called for a solution. The construction of the fourth Elbe tunnel pipe with 2 additional lanes will not only alleviate present congestion, but prepare Hamburg for future traffic volume. What at first appeared a simple problem to solve has turned out to be difficult, since the new pipe will run under the densely populated northern slope of the Elbe. The fourth Elbe tunnel pipe is being driven forward on the mining principle over its entire length of 2.6 kilometers by a tunnel boring machine. By using the very newest technology, it is possible to cope with the various types of soil encountered along the tunnel's axis. Within a period of 2 years, this machine will construct what is to become the largest underwater tunnel in the world in unconsolidated material. The diameter, 14.2 meters. The environment, shipping and local residents will not be affected. This giant project is being undertaken by the German federal government, represented by the free and Hanseatic city of Hamburg. The work itself will be carried out by a total of 7 construction companies, the fourth Elbe Tunnel Pipe Team. The various soil types along the tunnel route present a serious challenge for the tunnel boring machine. They expect to encounter sand, rocks of up to 2 meters in diameter, basin silt, glacial loam, peat, micaceous silt and clay, and boulder clay. In addition to this, there is the water pressure on the machine. This can produce a water column of 46 meters during a storm surge. An order of this magnitude can only be managed successfully if the tunnel boring machine is perfectly adapted to local conditions. Herrenknecht rank among the world's leading manufacturers of so-called liquid-supported tunneling machines in loose soil. For this reason, Herrenknecht were commissioned to plan, construct and install this high-tech machine.
Lager in den Dimensionen. Wir haben hier einen Lagerdurchmesser von.
Before all general conditions that the drilling machine must fulfill were specifically defined, numerous discussions were required between the engineers working on the large fourth Elbe tunnel pipe and Herrenknecht, the company commissioned to build the tunnel boring machine. Solutions were formulated and the details planned and carried out. At the same time, work commenced in Hamburg on the starting shaft. Here, the drilling machine began its long journey under the Elbe. The shield driving machine was set to cross the Elbe from south to north under 7 to 13 meters of overlying ground. Then it passed under the residential buildings on the northern bank of the Elbe. The smallest distance between the ground bottom and the shield driving machine is only 9.5 meters. Overall, the machine travel distance is 2,560 meters. The southern and northern ramps connect with the fourth tunnel to the existing A7 motorway. Summer 1996. For transportation, the 2,000-ton machine was manufactured in segments. The largest driving shield in the world, with its diameter of 14.2 meters, consists of 5 main arms and 5 ancillary arms. It is equipped with 111 scraper knives and 31 disc chisels. The entire control and supply technology for operating the machine is located on the 600-ton trailer. Meanwhile, discussions, preparations and planning continued in Hamburg. March 1997. Herrenknecht now began with preliminary installation. After just 3 months, the complete complex was operative and ready for trials in Schwanau. Representatives of the city of Hamburg and the RG4th elbeE tunnel pipe could see for themselves that all the functions complied with the requirements laid down in the specifications. The rock crusher, able to crush boulders of up to 1.2 meters in diameter, and the erector, to move the concrete segments of tunnel lining with millimeter precision, passed their tough test with flying colors. The clients were satisfied with the performance. Schwanau, Hamburg. The machine was dismantled and transported by ship. July 1997. In the starting shaft in Hamburg, the tunnel boring machine grew to full size, segment by segment. Three mobile cranes were needed to lift the 380-ton cutting wheel into a vertical position and lower it into the starting shaft. Once mounted on the machine, the heart of the drill was complete. The great day arrived. The tunnel boring machine was given the name Trude.
Tief runter unter die Elbe. Deshalb taufen wir dich auf den Namen Trude.
Nicht nur für Hamburg, sondern für gesamt Nordeuropa ist das ein zentrales Projekt.
Es ist ein Zeichen für die Innovationskraft am Standort Deutschland.
October 1997. Finally, all was ready. Trude's 2-year journey about to commence. A journey in the course of which she would eat her way forward by 6 meters a day, gorging around 1,000 cubic meters of soil, the equivalent of 100 truckloads. Initially, Trude had only one trailer. After 25 meters of driving, she was given a brief respite. Now there was enough space in the starting shaft to install the second section of the trailer. The final tunnel lining consists of 2-meter-wide segment rings made of reinforced concrete. Each ring is made up of 9 sections, the so-called lining segments. The 8 standard slabs in a ring weigh 18 tons each. The final keystone is much smaller and positioned last. The lining segments were lowered into the starting shaft and moved to the lining segment crane by rail. This placed them on a conveyor belt. The erector then hoisted the lining segments with vacuum panels and placed them in the correct position. The hydraulic presses were extended for driving and jacks were erected as an aid to installation. The cavity created below the shield tail was filled with compressed cement mortar. As soon as Trude had worked her way 2 meters further forward, a new ring was inserted. In this way, the tunnel was built piece by piece. After approximately 2 years, Trude had reached the end shaft on the northern side of the Elbe and, in the course of this 2,560-meter journey, had removed 410,000 cubic meters of soil. To prevent water or soil entering the tunnel, the machine created supporting forces that are stronger than both the pressure of water and the soil combined. These forces were attained with the aid of a viscous suspension, bentonite. Air pressure was added to this for support. The earth removed by the cutting wheel was mixed with the bentonite, pumped to the surface and separated in a separating plant. Boulders lodged in the soil were detected by the seismic advanced detection system built into the shield. The excavating tools blunted during the course of the shield's travel and were replaced when necessary. In the past, this work was done by specialist divers working inside the bentonite suspension. To simplify this complicated process, it was now possible for the first time to move around inside the main arms of the cutting wheel. The tools could now be replaced under atmospheric conditions from the inside without the need to enter the highly pressurized bentonite. 2nd of March 2000. Trude made the breakthrough. After 561 meters of underground travel, she broke through precisely in the target shaft in Hamburg-Ottmarschen. The 4th Elbe tunnel pipe was completely driven through. In the company of numerous celebrities, the children who named Trude, Jana and Paul, welcomed the giant as she returned to the light of day. Trude's breakthrough marks a further milestone in the history of tunnel construction. The massive diameter of the tunnel, the extremely complex geological conditions, and a maximum water pressure of up to 5 bar have made considerable demands on both machine and the ARGE 4th Pipe project management. Both man and technology have set an example of just how successful such teamwork can be. With a driving power of up to 14 meters a day, the largest tunnel drilling machine in the world played out a convincing performance. In the weeks that followed, Trude was dismantled and returned to the manufacturer in Schwanau. There, the mix shield is being prepared for the next assignment. In Moscow, a new challenge is waiting. Driving through 2 tunnel pipes of 2,080 meters for an urban freeway in the district of Lefortovo. In Hamburg, work continues on the completion of the 4th Elbe tunnel pipe. A Herrenknecht excavator compressed air machine will shaft the south and central escape tunnels between the 4th and the 3rd pipes using the pipe driving technique. The machine is installed transversely in the 4th pipe of the Elbe tunnel from where it begins. With pressures of up to 2.9 bar and a 14% incline, it will drive with millimeter precision in the direction of the ventilation building for the existing 3rd Elbe tunnel pipe and connect the tunnel structures. By 2002, everything will finally be ready. the fourth pipe can begin operations and traffic on the A7 motorway will be set to flow unobstructed on 2 to 4 lanes in the area of the Elbe crossing. Tailbacks will then be a thing of the past.